All right. Hope everybody can hear me and see me okay. And maybe if so folks can spotlight me, that'd be great. Hi, everybody. I'm Dan Garcia, UC Berkeley teaching professor. This talk is going to be about explainable generative AI with N-grams. It's hard to follow those wonderful presentations. So generative AI is all the rage now. And there was a delightful, I actually think this is my slide. I think this is the mother of all Snap Gen AI demos. There's a classic 1968 mother of all demos demo that happened in which 10 technologies you hadn't seen before all demoed in the same place. It was wonderful. Robolot 2024, Jens and Yaga, with the title "Building Blocks for AI with Snap," they showed almost in real time, starting from a blank project or mostly a couple of blocks done, how you could put together a generative AI demo that both was able to generate using N-grams, generate text with a beautiful story that wove 30 different stories together, music with 20 different songs, and sketches. I was absolutely blown away. Absolutely blown away. So I put the link here. Please watch this video. I put the link exactly to where that talk starts. It's amazing. So I was just wrapped with this project. I've been playing with it and been using it in class for months and months since then. I wanted to kind of explain to you all, those of you who didn't attend the talk, I want to kind of give you the high level what they showed, and then I wanted to be able to play with it because I ripped it apart and played with some things and added some things, and I'll show you a demo of that. Hopefully the sound will all come through. So they have two stages to this generative AI project. The first is model training. They start with a linear sequence of tokens, and those, if we're talking about a story, the tokens are words. So they take these 30 short stories and they just linearize them into one long list of all of them back to back to the 30 stories. They also did this. What's amazing is the same two blocks is the beauty of abstraction, right? The same two blocks worked when they took 20 songs where each token was a note and a duration, and they just concatenate them all together into, again, one long song, which you can just play. You can just say, play the song. It'll go from one to the other, to the other, to the other, like a long playlist, if you will. Then they showed this unbelievable demo that has a drawing in which they just do a little sketch, like signing your name, and then they say, generate a sketch that's like the way I just signed my name or the way I was drawing, say, a skyline of New York or something. I was absolutely blown away. So how this works is it's based on the fundamental of an N-gram. And so there's a little beautiful picture I put in the bottom, which is if you just have this as a sentence, and then you take a sliding window and slide it across, if the window's only one word wide, and every time the window snaps to the next cluster of words, you then add another row in your N-gram. So if the window is only one wide, it basically chooses every word and says, this is a sentence. If you make the window 2 words wide and slide that from left to right, you get this is a sentence. And you might imagine this goes on for a very long, remember, we're concatenating 30 stories together. So this is a really long list of this, or again, 20 songs together. Now, if you have it 3 wide, that's called the bigram or 2-gram. If you do a 3 wide, it gets a window of 3 words and you slide it across left to right. This is a sentence, etc. Okay. And so they do this for the 1-gram, which is you see on the left, the 2-gram in the middle, the 3-gram on the right, and also the 4-gram and the 5-gram. And that's the model training. It's very fast. It's not the traditional model training you think of as is farming up spinning up an AWS sequence online. It just basically builds these 5 tables, and we call that our model. So again, I'm trying to highlight the code without showing you the code, just to kind of give you the top level picture. And for free to ask any questions online. Then you've got model inference. And the inference is, okay, now I got this model. What do I do? How do I generate the next word? And so I just love this Wallace and Gromit picture, which is essentially, this is one of the most delightful claymations sequences of all time, where you've got a stack of these tracks and you're feeding to the next word. So how this works is you use the model to find a new token and add it to the end of the story, like adding the next track to the end of the train track. And then you do it again. I've got a model and I figure out what the next word is. You just keep adding the next word to the story, and this story can go on forever, or the song can play forever, or the sketch can be drawn forever. Okay. So here's the simple algorithm. Here's how this works. You start by saying, let's find all the places where the last four tokens of the story, remember, the story could be a story of words or of music or of sketches, and it's actually the sketch delta, the difference of where the pen was from the last time. So it's basically a number from 0 to 360. So whatever those tokens are, you look for the last four tokens, and you look for under the 5-gram, and you say, are there any places where the last four words for tokens in the tokens of a story, it's really not story, it's a more generic thing, but for tokens of the story, match the 5-gram? Okay. If there's a match, I pick randomly. Otherwise, I look for the last three in the 4-gram. Otherwise, I look for the last two in the 3-gram. Otherwise, I all get down to the 1-gram, and the 1-gram is all the linear tokens, just pick randomly somewhere. So basically, it's a very simple algorithm that they show beautifully in the mother of all demos how to do this. And so I want to show you an example of how they do this. If I have the phrase once upon a time, that's what I start with the story, right? Once upon a time, okay? Well, here's a small snippet of my 5-gram table that I've got, right? Which is a window of 5 words. And now what I'm doing is looking at the left 4 words and say, show me when the left 4 words match once upon a time. And you see it matches 4 different times. Then all they do, very simply, it's a beautiful keep that just keeps all the ones in which those match. And then it says, now pick randomly from whatever is on the right of the ones that matched, which here's 1, 2, and 4, and 5. And you'll notice that there are 2 thes. So there should be chosen half the time. A should be chosen a quarter of the time, and Alonzo should be chosen a quarter of the time. And so this, without any of the mathematics of making a table and a frequency table, it just says, look, it's going to do the right thing probabilistically and choose the half the time and the other one's a quarter time. And essentially, it's never extrapolating. It's never picking a word that wasn't in our corpus. It's either picking the 5th word of a sequence of 4 words, or it's picking a random word if somehow that doesn't work. Okay, so that's it. And you basically have this Wallace and Gromit situation where he's continually adding words and words and words and words and words. And it's really beautiful and really wonderful. And so I played with this and it was awesome. And I was exploring this. And then here's the catch. By the way, what I wanted to know. So this is what they demoed. And I was playing with this I've never had a project I played with so much. It was so good. This is just so good. But then I realized, those lines came from these stories. Let's say Frozen had the first 2, and then Hamlet was the middle one, and then Godfather has the 4th one, and the Avengers, some story about the Avengers, had the 5th one. Okay, you can train this on anything. Those weren't the ones they were training on. I'm just showing this as an example. And I wondered, how do we know when I pick was the from Frozen or was the from Godfather? And so this was my piece of the story is weaving, but am I continually playing a Frozen story? Is it just literally always grabbing a Frozen story? Or is it grabbing from, say, The Godfather and jumping back to Frozen and jumping to Hamlet? I wanted to know where the stories were coming from. That's what I approach this with, trying to solve that problem. How do I know what that is, where the original story was, and how it's then moving between stories, kind of in a beautiful, natural way. It's kind of jumping between the stories. I also wanted to know what other stories could it have jumped to. So that's why I started this project, by thinking about this and trying to solve that problem. Okay, so once I did this and I built this in the system, and then I realized there were 2 really small problems. And the first is, if nothing matches ever, which means it only picks the one, if there's no repeated 4 phrases, if that makes sense, if all of these, I'll go back to this, are all unique, meaning there's only one once upon a time, and there's only one to be or not to be. And every group of 4, you might imagine if I concatenate, just as an example, 30 stories in which they're all in different languages, right? Then that means, and every time you'll never have any repeat stories, any repeat groups of 4 phrases in itself within its same story, then it will basically just play there's a song now, it'll play the first song, then the next song. It'll just essentially continuously just play this song linearly, like the playlist. It's not jumping from song to song because there's no matches. You have to have matches. So if you train your model on 1 through 5 N-grams, then you have less of a chance of jumping around from story to story, because you have to match exactly 4. That means the last 4 notes have to somehow be in the other songs. And if not, it'll just choose the next note in that song. So that's problem number one. Problem number two is, what if there repeat melodies in the same song? Okay. So here's a phrase. Here's a very simple story I came up with to try to demonstrate this. Once upon a time, there was once upon a time, once upon a time, there was a once upon a time looping story. Okay. So here's what could happen. I go to the first once upon a time, and it now is looking for any window of 4 that matches. Notice there's 2 times once upon a time happens, once upon there, or once upon a time there, once upon a time looping. Let's say it chooses there. Okay, so that's great. So it moves ahead. And now it keeps going. Once upon a time, there was because none of these there's no other matches. So it keeps going. It's only finding the next word in the sequence. And now it gets to the next time it sees once upon a time. Remember, it's looking for a pattern of 4 that it's seen before. And because here it's seeing within the same story. Well, here's the word there. Here's the word looping. You kind of wanted to say looping so it keeps going, or jump to another story ideally. But what if it picks there over and over and over? So you're going to get exactly this story. Once upon a time, there was a, once upon a time, there was a, you see what the problem here? Once upon a time, there was and you'll never get out of this loop. If it happens to continue, always pick the there, it'll get to looping and almost like jump back to there and keep going, and you won't get out of this loop. And so here's the fascinating thing. I'm going to hopefully play this, and I'm going to show you the visualization. So now we're up to, so we can reduce this chances, by the way, if we only use up to 3 grams, because almost like a live wire, if there's higher chance of jumping out of that and there's other places it would match, it's better than having 4. So if you have a 5 gram, it'll have a higher chance of this loop, and you're going to hear this in the song. That's it. Now it's time for the demo. Stop talking, Dan, and go to the demo. All right, so let me go to the Snap window. And let me here we go, new share with sound, my Snap demo here. Okay, and hopefully you can hear this. So this is a really big 4K window of my project. What I did was I took their project and I simplified to this. So the first thing I had to do was they just had a list of, in the 20 stories, it was just one big flattened list. I had to recreate, so if I click this, you'll see that on the left, this is the sequence of songs for this. If I make this a little bit bigger, there are 20 songs, and these are the 20 songs, and these are the notes and durations for those songs. So I had to kind of make a table. So I had to unflatten, if you will, the songs and then add the titles. So that's the starting point. And so now this code, in theory, where I've only done this for the songs because the songs was really the most engaging. So you have to kind of take a flattened list and put into this structure. Once you have this structure, that's all you need. That's really all you need. You train, and I call this explainable AI because it's going to tell you where the song came from. And that's all start. So let me turn this off to show you, just play one of the songs. So here, hopefully somebody give me a thumbs up if I get, if you can hear this. Okay, let's try it. Let's go to the first song. Here we go. And let's try it. Click here and click there and there. Thumbs up if you can hear it. Yes. Okay, great. So this is just one song, Twinkle Twinkle, and you can just play with it. So I made this. This is just the simplest how to show the different songs. You can change the tempo, but this is My Body Lies Over the Ocean. Okay, great. So now it's time for the demo. This is the fun part. So we're going to train it on the 5 gram, and what you're going to listen for is anytime the song literally gets stuck in the same song, like I mentioned before. And also notice that very often it'll play one full song, then jump to the next and jump to the next. So this is Explainable AI that I created, which is a table in which the columns are all 20 songs. When you see a heart, it means it shows that particular song. If you see a black square in a row, it means it could have jumped to that song. And it didn't. Okay, so black square means it could have jumped away from, and by the way, what this doesn't show is how many times it was repeated in the same song, but you'll hear that to notice that. So here we go, ready to go. And by the way, this project is live for you to play with this on this. Here we go, let's do this. I play it. And I'm gonna turn this off, turn these off. Okay, give me a second. Listen to it. Uh-oh. Okay. That. And this. Grab it with my mouse. Here we go. Okay. Aha, it jumped. But notice, it's mostly staying in the same song. So there's no 4 notes, durations that match any other song. And by the way, I can actually make it go a little faster. See? Playing the whole song. This is exactly the problem with the 5-gram. And now just goes to the next one. And here, look, notice this. It could have jumped, and it did jump for 1 note, but then jumped back. So these two match, actually. Super neat to see how this happens. So it's like, it's not so Gen AI. It's just basically playing song after song. And I can even speed up a little more. See? Oh, there we go. And so you're noticing there's a couple of these songs that have some time in the middle, but often, see, now, so, okay, now we jumped. There we go. So you can see it's possible to jump around in these. So now what we're going to do, just for fun, the Amazing Grace, and lots of self loops. Just listen. It keeps jumping back to earlier places. We might be in with Amazing Grace for a while. By the way, the time you saw all the black lots, that means it got to the last song, and then it says, I don't find any other matches because there's nothing else, and it jumps to any of the other ones, and that's why you saw one black line to them. So Amazing Grace has the problem, there's lots of repeats, so once you get to Amazing Grace, it actually, with the 5-gram, it'll actually stay in Amazing Grace for a while. Let's see if it, okay, it's not an Amazing Grace, I just wanted to see that. All right, I'm gonna now stop this and go to the 3-gram. And the 3-gram is really good. And I think the demo they actually showed is the 3-gram. But I said, well, why is it 3-gram? So let's now do the 3-gram, and you'll see how it really does jump quite a bit, and it's really wonderful. And I just often, this is crazy, I often have this in the background playing different songs because it's just so good. So the 5-gram Amazing Grace does loop. When it gets to Amazing Grace, I didn't get to do that, but it will actually stay in Amazing Grace for a long time because it's showing you these self loops and jumping back to itself. Super interesting. All right, let me now finish this one off with the 3-gram. I train it on 3. Let's do this. Let's full screen this. And now, and you'll see, let me, if I can grab the corner. Right there. Okay, here we go. Here we go. And notice how, look at how much more black there is. It's meaning I can jump all around. And listen. Way more interesting when you're only looking for 2 matches. And Battle Hymn of the Republic, and the 4th one are very similar. Daisy, nothing matches, really. But you see, what's cool is you also see patterns saying these 2 songs are actually close together because it's very easy to jump back and forth. Maybe turn it up here. Daisy, nobody really matches Daisy. So I just love watching this pattern. I love listening to it. It's so fun to load in songs that might be similar, that you don't realize are similar, and watch they actually are similar in that how they're jumping back and forth between the songs. Super interesting. Amazing Grace, which could jump out. It finally did jump out. So anyway, that's my demo. Just wanted to show this. I call this explainable AI because in some sense, it's answering the question, where did that sound come from? It's not really traditionally explainable AI, in which you want to have a neural net tell you why it decided what it did. But in some sense, this is a Gen AI system telling you why it decided to choose the songs it did. Thank you so much.